In this video session, I'm going to explain 8-bit magnitude comparator using IC 7485. As we know, this IC is a 4-bit IC. It's a 4-bit magnitude comparator IC, but we are going to make a 8-bit magnitude comparator by cascading two ICs of 7485 and make a 8-bit magnitude comparator circuit. So as its theory we have already discussed in a theory lecture. So just I'm going to go for a general idea and then we go for connections. So to make a 8-bit IC, so first we join two ICs. First IC 7485 IC1 treated as a LSB IC. Second 7485 IC2 treated as a MSB IC, because whatever inputs are going to join here on LSB sides, so that inputs are treated as a LSB inputs and this inputs are known as MSB inputs. So in this IC, general as per pin diagram, so 8th pin is normally going to join to ground, 16th is to VCC. So now this connection is known as a cascading input connection. So this is a first IC. So we are going to join this connections as an external. So in this IC, by using comparator, we are going to compare 4 bits with 4 bits. So means A0 to A3, these are the 4 bits. We are going to compare it with B0 to B3 and check the results, whether the result is A greater than B, whether the result is A equal to B or A less than B. So initially, as a cascading input connection, this middle one pin number 3, that is for A equal to B, that is connected to a VCC, and other two, A greater than B, A less than B, is connected to a ground. So this is known as a cascading input connection. Now output of this IC is on pin number 5, pin number 6, pin number 7. So output we know A greater than B, A equal to B or A less than B is going to cascade to a second IC with the pin numbers 4, 3, 2 as a cascading inputs, because on pin number 4, 3, 2 are cascading inputs and pin number 5, 6, 7 are the output pins for the specific IC. So we are going to cascade output of first IC to a input of second IC. So that's why we made the connections like this. Similar way, output of a second IC is on similar pins 5, 6, 7, same outputs, A greater than B, A equal to B, A less than B. Then these connections are same for both the ICs, and then on both the ICs we need to connect 4 pins for B, 4 pins for A, because we are going to compare bit by bit. But this is a 4-bit IC, so at a time we are going to go for a 4 bits, A0 to A3, B0 to B3. But for this IC it is treated as a LSB inputs, and for this IC same A0 to A3, B0 to B3 is treated as a MSB inputs. So now we are going to verify this circuit by using a truth table. So in that truth table, we are going to connect some inputs and check which output is high, which one is output. So that is going to connect to 1. So now we go for connections for this IC. So for this connections, to make a circuit, we need two 7485 ICs first. So we joined two ICs 7485 on 2 sockets of this section in a IC place holder. So now Next connection we are going to go for 8 ground. So we need to join 8 ground. So first thing we check this IC is for how many pins? This IC is for 16 pins, right? So we are going to check where is our 8 pin on this IC. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is on the ground. Similar way. 1, 2, 3, 4, 5, 6, 7, 8. It is on the ground of both the ICs. Then we go for a connection of pin number 16 to VCC. Pin number 16 we need to join to, pin number 16 to VCC. So we now completed these 2 connections, right? So next, for a second IC, we are going to make this connection, but need to join this to output. So on this board, we know this is the output section, output and input section. So we can treat any row for input, any row for output. So now suppose here, I am going to use last row for output. So I make the connection here, make the connection here, make the connection on this notch. Yes, perfect. So first connection on a 5th pin of second IC. So where is the 5th pin of second IC? 1, 2, 3, 4, 5. So this connection I have finished. 5th, join on 1st, 2nd, 6th. So where is the 6th pin? Where is the 6th pin? So already we make a connection. Yes. Then 7th. So where is the 7th pin? We need to check. So this is the 7th pin on this board. So we know, okay, this is the 7th pin. So we are going to join this. So now we have finished these 3 connections of output for this second IC. Now we are going to go for this connection. This is the first IC cascading input connections. So we need to join first one to pin number 4. So where is pin number 4? 1, 2, 3, 4. So this is pin number 4. Need to connect to a ground. So I need to join it to ground. So next, pin number 3 to pin number 3 to VCC. Then pin number 2 to ground. So here is the ground connection. So now this way we have finished this section, that is 4, 3, 2. Now we are going to shift to this cascaded section, output of first to input of second. So means we need to join 5th pin of first IC. 5th pin of first IC, where we check where is the 5th pin of first IC. So here is the 5th pin of first IC. I need to join to 4th pin of second IC. So this connection. Then 6th pin of first IC. So here is the 6th pin of second IC. It needs to connect it to 3, pin number 3. So here is the pin number 3. Then 7th pin of first IC need to be joined to pin number 2. So now we have finished this part, completed this section. 5 of first to 4 of second, 6 of first to 3 of second, 7 of first to 2 of second. So now we are going to make this connection, input connections. So for input connections on this board, we are going to use these two lines for input. One is for A and one is for B. So directly we join 4 connectors on this board, like 1, 2, 3 and 4. But I need to connect here on this circuit. I want total 4 plus 4, 8 plus 8, 16 connections. But on this board only less connections are possible. So means 4 plus 4, 8 are possible. So I can join MSB and LSB on a same row. Like this way I can join. So these are the A connections. Now for B connections, so for B connections I am going to join black one, so this is the B connection, right? Now 4 connections are there, so I want again 4, so I need to join this. 1, 2, 3 and 4, because I know I'm going to join it on a same point on the IC. As per this circuit diagram, whether it's a LSB or whether it's a MSB, both are going to join on the same pin numbers. So with this circuit diagram, I have completed all these connections of LSB input, MSB input on this board. Means whatever connections are here on this pin numbers, I have to join on the input section. So I have connected all that connections here on the input part. So on the input part, I have considered first row for B, second row for A. So now I need to verify first whether all the connections are completed. Yes, this one, this one, this one. So we have finished all. So now we are going to test the truth table, right? So a basic truth table, suppose we go for, we are going to make first B to all 1, right? So we know this section, this first row of our input, we used it for B. So I make it on, right? And I keep A values as 0. So that easily we can verify that yes, A is less than B. So this one. So see here. So this last connection is for A is less than B. So this LED is on. So we have tested this. Now I make this off, and I'm going to consider an opposite case where I'm going to make all A values are equal to 1 for this case, right? So second section I'm going to keep on, all the LEDs are on. So that means my A value from A0 to A7, LSB and MSB values are 1, and I have taken B as 0. So now I'm going to check the output. My first LED is glowing. So that is for A greater than B. So this first one, right? Now any other case, suppose I mention some other combination. Suppose I have taken where I have to take other value. Suppose I consider 1 0 1 0. So for A I'm going to take 1 0 1 0, right? And then for B I'm going to take an all 1. So in this case, your A is less than B, output should be high. So see here, so we are going to get the output A less than B. This is the third combination, because this one is for A greater than B, this is for A equal to B, and this is for A less than B. So when you consider an input for B as a 1 1 1 and A 1 0 1 0, so this case I'm going to refer this case, first case, B all 1 and A 1 0 1 0. So in this case I know B is greater than A, so that's why for the output your last combination is high. Okay, so in a similar way you can test any combination on this board. So like I'm using this for input. So suppose I want to keep all 1, right? Now all are 1. I already make B is already equal to 1, right? So if A is 1, all digits from A0 to A7, and for B, B0 to B7, all digits are 1. So our output should be equal to A equal to B. So this is the middle one is as a output for A equal to B. So this LED is glowing. So now this is the way how you are going to test the circuit for 8-bit magnitude comparator, right? So these are the connections. So all the connections are little bit complex, but make sure you are going to keep a pin diagram in front of you, and then you are going to make all the connections. So then 100% we will get the final result. Thank you.